Welcome to Mathematics Online Lecture Series, lecture number 10. Change of variables in double integrals, Cartesian to polar coordinates by Professor K.V. Narasimhan, London Institute of Engineering and Technology, Vijayanagar. Today we will discuss a new problem. Evaluate double integral, integral 0 to 4a and integral y square by 4a to y x square minus y square by x square plus y square dx dy by changing into polar coordinates. Suppose if you change into the polar coordinates, now this integration is very simple. Easily we can evaluate the integral. Now what is the solution? Now if you observe, so this limit, now this limit, if you observe this limit, that integral limits are in terms of y, that's why this is x. So other variable is 1. Now x equals to y square by 4a to y and y equals to 0 to 4a. Now integrand is same. Now if you observe this, first we will observe the region. What is the region? First we will observe the region. X equals to y square by 4a. Now rewriting the term y square, x equals to y square by 4a, x equals to y square by 4a, then y square becomes 4ax. It is a parabola to x equals to y. It is a straight line. Y equals to x is a straight line, and y limits y is 0 to 4a. So the region is bounded by x equals to y square by 4a and x equals to y and y equals to 0, y equals to 4a. Now what about the diagram? So lower limit, this is a x-axis, this is y-axis. So x square equals to 4ay is nothing but y square equals to 4ax. It is a parabola. Y square equals to 4ax is a parabola. This is y square equals to 4ax. Y square equals to 4ax. Okay. Then x limit x equals to 1. So x equals to y is a straight line. Now this is y equals to x or x equals to. So if you observe x limits along x-axis. So lower curve is we'll take red curve. Lower curve is this one. Lower curve is parabola to y equals to x or x equals to y. So first limits along x-axis. Assume along x-axis from this one. First curve is y square equals to 4ax and another curve is y equals to x or nothing but x equals to y square by 4a to y. Now x limits. Now point of intersection of y equals to x, these two, y equals to x and this one is nothing but y equals to 4a. Suppose if you put y equals to x here, so x equals to x square by 4a. Now if it goes to the left hand side, x square minus x into 4a equals to 0. X into 4a. That's all. X into 4a equals to 0. Now common x in these two terms, you will get x into x minus 4a equals to 0. Now x becomes 0 and also x equals to 4a. So when x equals to 0, y is also 0 here, first point of intersection, other point of intersection is 4a, which is shown in this diagram. It's a clear diagram. So this is y square equals to 4ax. This is the straight line. Now this is straight line. This is the parabola. Now point of intersection one is this one and this one. Now this is the given region R. This is the given region R. In this region, we'll now change into the polar coordinates. Now, if you observe in terms of theta, polar coordinates, this straight line, y x equals to y. X equals to y is nothing but what are the polar coordinates? What are the polar coordinates? X equals to r cos theta, y equals to r sin theta, dx dy equals to r dr theta. Now x equals to y, if you equate these to x equals to y, r cancel, then what happen? Cos theta equals to sin theta. Cos theta equals to sin theta. That is tan theta equals to 1. Tan theta equals to 1 means theta equals to pi by 4. Theta equals to pi by 4. So this straight line is nothing but theta equals to pi by 4. So our angle up to this curve ends at here. Here theta equals to 90 degrees clearly. You can observe this is pi, theta equals to pi by 4, here pi by 2. Now theta limits. What about the theta limit? Theta is pi by 4 to nothing but this line to this line. Pi by 2 to pi by 4. Pi by 4 to pi by 2. Okay. Now what about R? R radius vector moving on this on this curve. What is the curve? On the what is the curve? X equals to y square by 4a. X is nothing but r cos theta. Y is nothing but r sin theta, r square sin square theta by 4a, and substitute the x value and y value. What happened here? R cancel. 4a cos theta equals to r into sin square theta. R becomes 4a cos theta by sin square theta. So radius vector, now this is the radius vector moving on this curve. Initially it is 0 and it is moving on this curve is nothing but r varies from r limits 0 to this 4a cos theta by sin square theta. Cos theta by sin square theta. Sin square theta. Now we will evaluate this integral. Now this is the given integral. Now the r limit 0 to already discussed 4a cos theta by sin square theta. Theta limits already we discussed here, pi by 4 to pi by 2, pi by 4 to pi by 2. Now substitute the x values and y values in this expression. X is nothing but r cos theta, r square cos square theta minus r square sin square theta by r square cos square theta plus r square sin square theta dx dy equals to r dr d theta. Here r square is the common term, here r square is the common term, both are cancelled. Then what happened? Cos square theta minus sin square theta outside. So inside function r times only separate r values and theta values inside only r. R limit 0 to 4a by cos 4a cos theta by sin square theta. Integral r equals to integral r dr equals to r square 2 by 2. R square 2 by 2. Now theta is pi by 4 to pi by 2. So r limit is r square by 2. Limits are 0 to 4a cos theta by sin square theta into cos square theta minus sin square theta d theta. Now first put theta equals r equals to 4a cos theta by sin square theta. 1 by 2 is the common term, whole square minus. If you put theta r equals to 0, this becomes 0. No need to write. No need to write because r is 0. No need to write. Now simplification. Here 4 square, that is 16 a square by 2 into cos square theta by sin square theta whole square is sin power 4 theta. Now here cos square theta by sin square theta is cot square theta. So in the denominator we have sin square theta. If it goes to inside bracket, cos square theta by sin square theta is cot square theta, sin square theta minus sin, but sin square theta by sin square theta is 1. Now just simply this is look like cos square theta by sin square theta minus sin square inside the bracket term sin square theta by sin square theta. This term is cot square theta, this term is 1. Now this is clearly. Now we know about trigonometric identities. One of the identity. 1 plus cot square theta equals to cosecant square theta. 1 plus cot square theta. Cot square theta equals to cosecant square theta. Cosecant square theta. Cosecant square theta. Now using this one, cot square theta is cosecant square theta minus 1. Now previous term is same. Now separate into two integral. First term cosecant square theta into this term, then 1 into this term. 1 into this term is this one. Cosecant square theta into cot square theta minus 1. Okay. Now here 16 by 2 cancel 8a square. Now you will get 8a square theta is pi by 4 to pi by 2 cosecant square theta into cot square theta minus 1 d theta minus integral pi by 4 to pi by 2 cot square theta minus 1 d theta. Now first term is same. Now change. Now in the second term again we are using the same identity 1 plus cot square theta using this identity cosecant square theta minus 1 already minus 1 here. Now same step. Minus 1, same step. Just only for understanding. Again, we are writing the same term. Okay. Here, first multiply these two. Cosecant square theta, cot square theta minus cosecant square theta minus 1 is nothing but cosecant square theta. Already here cosecant square theta, 2 cosecant square theta minus 1 minus 1 minus 2. If you common 2, you will get this term. Okay. Now, integration. Suppose if you assume cot theta equals to t. Cot theta equals to t. What happened? Minus cosecant square theta d theta equals to dt. Now already cosecant square theta is there, so you will get negative sign. Now this term becomes t square. Integral t square equals to t cube by 3. T cube by 3. T cube by 3. T is nothing but t is nothing but t is nothing but t is nothing but cot theta. T is nothing but cot theta. Cot theta whole cube by 3. Now this time cosecant square theta integration is minus cot theta minus or minus plus. So integral 1 is equals to theta. Now substitute theta equals to pi by 2. First pi by 2 in the here. Then pi minus sign pi by 4. You will get this one. If you observe cot 90 equals to 0. Here cot 90 equals to 0. Pi by 2. Here cot pi by 4 is 1. 2 times here. This term. Pi 1 by 3 minus pi by cot pi by 4 cos 45 degrees equals to 1 plus pi by 4. Now if you observe 80a square, this is 2 times 2 minus 2 cancel. So you will get 2 times of pi by 2 is nothing but pi and 1 by 1 pi. Here 2 times of pi by 4 is nothing but pi by 2. Then 1 by 3. 1 by 3. Here, okay, not cancelled 2 here, 2 into 0, 2. Now, pi minus pi by 2, pi minus pi by 2, pi minus pi by, pi minus pi by 2, pi minus pi by 2, pi minus pi by 2 is nothing but pi by 2 plus 1 by 3 minus 1 by 3 minus 2. 1 by 3 minus 2 is nothing but 5 by 3. So finally we got the integral value. Double integral of 0 to 4a y square by 4a to y x square minus y square by x square plus y square ds dv equal to 8a into 5 by 2 minus 5 by 3. So this is the solution of the double integral. If you have any doubts, contact through my email ID and WhatsApp number. Thank you very much.